example, we're going to solve problems with geometric sequences. So we have a story problem and we're going to try to solve for that. In this case, we have a phone tree. So a phone tree is when one person calls a certain number of people. So we have this person here, and they call a certain amount of people, let's say 3 people. And then those people call 3 people. And those people call 3 people, and so on and so forth. So they call the same amount of people. In the 5th round of calls, 243 people were called. So we have 1, 2, 3. So boom, 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 boom. This is the 5th round. Draw a bunch of dotted lines to show discontinuity. And in this round, 243 people were called. They want us to write an explicit definition to find the number of people called in each round. All right, so the graphic shows us that we have 3. So my A1, the first round they called, this is A1. This would be A0, but we're going to start with A1. So A1 is equal to the 3 people that initial person called. All right, and then we know that A5 is equal to 243. Well, let's plug this in. Let's substitute this into my recursive definition. All right, so we have an is equal to, my explicit definition, a1 rn minus 1. All right, so I know a1, so I know a5, 243, is equal to a1, which is 3, times rn minus 1. So this is a5, so 5 minus 1 is 4. All right, so now I just isolate r, and I get 81 equals r4. Take the 4th root, and I believe this is 3. So 3 is equal to r. So my explicit definition using the information given is a sub n equals 3. This is the a1 amount, a1 value, 3. This is my common ratio, n minus 1. Sorry, I hit the volume key there. Okay, so how many people were called in the 8th round of the phone tree? So we're going to try to find how many people were called in the 8th round of the phone tree. So I'm going to do a sub 8 equals 3 times 3. 8 minus 1 is 7. All right, 3 times 3, this is essentially 3 to the 8th power, so A8 equals 6,561 people. So on the 8th round, (6,561) people were contacted. Alright guys, so again, this is just looking at how you could find, given 2 data points, how you can actually find your common ratio. You can actually do this with non-A1s, and it's a little bit more difficult. You got to factor in how far you are away from the other one, but again, these are just common ratios. So this is not too bad to find your common ratio. Again, if you have any comments or questions, please feel free to ask, and I'll see you in the next video.